Step one, I don't know how to solve these problems without drawing a picture. So I'm going to start by drawing a picture of a cylindrical can. There's a cylindrical can. And the can is of radius 8 and of height 9. And it's partially filled with water. So there's partially filled with water. And they're not giving me any more specs about that water at the bottom there. So I'm just going to label that as H for its height and its radius as R. But note that R is always equal to 8 because it's an upright cylinder, and so its radius isn't changing. I'm interested in the volume down there, and I'm given that the volume of the water is decreasing at a rate of 527 cubic inches per minute. So dV dt is equal to minus 527. We can play the unit game, but I'm just going to kind of omit the units for now, if that's okay. And they're asking me, what is the rate at which the height of the water is changing? So we're being asked dH dt equals question mark. And so from those two things, I know that I need to relate V and H. And that's going to come from the statement that the volume of a cylinder is equal to pi times R squared times H. And initially it looks like maybe I'll have to do some sort of like similar triangle game, except that we don't have triangles here. We just have an upright cylinder. And so we realize that, oh, this is actually equal to 64 pi H, because the radius is always 8, and 8 squared is 64. And once I have that constituting equation, now I will differentiate. I'll differentiate with respect to time. And I'll know that dV dt is equal to 64 pi times dH dt. Right? The volume is changing and the height is changing. 4 sub dV dt equals minus 527. H equals 5. We already substituted the R, and so that's going to tell me that minus 527 equals 64 pi times dH dt, and dH dt was my unknown. And finally, 5, solve for dH dt, and I'll have that dH dt is equal to minus 527 over 64 pi. I think another common mistake is to not have pi in the bottom. The arithmetic in this problem was a bit simpler than the previous problem because the radius was always the same. H is 5 because, look, when the height of the water is 5 inches. It ends up being irrelevant because, like, the shape of the can doesn't depend on the height. You know, like if this was a vase, you know, think about like filling up a vase for flowers where like there's a bulb at the bottom, and like, have you ever like had the experience where like you're filling up the vase and it's like it's going pretty slow, but then like you didn't turn the water up and all of a sudden water just comes flying out of the top of the vase because like it tapered down and was really skinny at the top? Have you ever had that experience? That's going on here. That's related to what's going on in terms of the cone and the cylinder, except the cylinder is like, it's the same. And so if you fill it at constant rate, then the height is going to change at a constant rate also. Stop there and say thank you very much for your kind attention.